Tonight, we are going to dismantle an image that has been sitting quietly in your mind since childhood. The picture of loneliness, the empty room, the astronaut floating alone against the black, the single small figure against the dark of space. You have carried this image for as long as you can remember. It is the picture you reach for when someone asks what isolation looks like. A figure, a distance, a silence. But that picture is not what loneliness is. Not really. Not on the scale we are about to enter. Tonight, we are going to ask a single, strange question. A question so unsettling that by the end of these next 2 hours, the word lonely may not mean what you thought it meant when you first sat down to listen. Here is the question. Where in the entire universe is the loneliest place? Not the loneliest person. Not the loneliest planet you have heard about in passing, the loneliest place. A single location so cut off from everything else that, if you stood there and turned in every direction, you would find no proof that anything else existed at all. It sounds like a simple question. It is not. The answer is not on Earth. It is not at the edge of the solar system. It is not on the cold side of some forgotten moon or in the deepest trench of the deepest ocean. The answer is much further out, much stranger, and much larger than almost anyone allows themselves to imagine. And by the time we arrive at it, the question itself may no longer feel like the right thing to ask. Before we go any further, one small request. If you find this kind of slow, careful exploration of the cosmos calming, or fascinating, or worth your night, a single tap on the like button or a quiet subscribe genuinely helps this channel keep making these long journeys. It costs you nothing. It means everything on this end. And then we begin. Now, settle in. There is no rush tonight, because tonight we are going to follow a thread. We are going to start somewhere familiar, a place you could find on a map, a place you could, in theory, visit. And from there, we are going to move outward, slowly, layer by layer, until the familiar things begin to fall away. We will pass the most distant object that human hands have ever built. A small spacecraft, almost 50 years old, drifting toward a boundary no machine has ever crossed before, still whispering back to us across the dark, in a voice that takes nearly a full day to arrive. We will keep going. We will meet worlds that have no sun. Planets the size of Jupiter, drifting alone through interstellar space, with no light to warm them and no star to call their own. The James Webb Space Telescope has now found hundreds of them. Some travel in pairs. Some carry the quiet beginnings of moons. They are not in any solar system. They are simply out there, wandering. We will keep going. We will meet stars that have been thrown out of their galaxies, hurled at over 1 million miles per hour by the supermassive black hole at the heart of the Milky Way. Stars that will never return. Stars that even now are crossing the dark space between galaxies, carrying whatever planets they had with them, sailing slowly into an emptiness that has no name. We will keep going. We will arrive at a galaxy so profoundly isolated that, if our own galaxy had formed in its place, we would not have discovered the existence of other galaxies until the 1960s. Astronomers have given it a clinical, forgettable name. The European Space Agency, in a rare moment of feeling, has called it something else. The loneliest of galaxies. You have probably never heard of it. Tonight you will. And tonight it will stay with you. And we will keep going. Because beyond that single galaxy lies something far larger. A region of space, 330 million light-years across, that contains almost nothing at all. A hole in the cosmic web so vast that the entire Milky Way, with its hundreds of billions of stars, could fit inside it many, many times over, with room to spare. Astronomers have given it the dull name Boötes. People who think about it for too long give it a different name, the Great Nothing, and even that somehow is not the end. Because what we are going to slowly uncover, layer by layer, is that the loneliest place in the universe is not really a place at all. It is something stranger, something that has been waiting for us all along, something that involves the very nature of time itself, and the very nature of you. Here is what makes this question dangerous. Once you start asking where the loneliest place in the universe really is, you cannot unask it. In the days after tonight, you will find yourself looking up at the sky and wondering whether the silence you see is the same silence the stars themselves are sitting in. You will look at the moon a little differently. You will think about Voyager a little differently. You will, perhaps, think about your own life a little differently, about what it means to be in a place, about what it means to have neighbors, about what it means to be a small, warm thing inside a very large, very dark room. And before we can find the loneliest place in the cosmos, we first have to understand something deeply uncomfortable. Loneliness, as you have always understood it, is a human invention. It is a feeling that requires neighbors to measure yourself against. It requires somewhere else and someone else to compare your distance to. And the universe, when we look at it honestly, has very, very little of either. So let us begin where every great story has to begin, with the place you think you already understand. The loneliness you think you already know, down here, on Earth, with a small island stranded in the middle of an ocean, with a graveyard sitting silently at the bottom of the sea, and with a single small spacecraft, almost 50 years old, slipping quietly across a frontier that no human-made object has ever reached before. Because before we can travel to the loneliest place in the universe, we have to first remember the loneliness you already know. And as you are about to discover, even that is not quite what you think it is. Start with a globe, the image you have probably seen 1,000 times. The familiar blue marble, slowly turning, with continents you know and oceans you have stared into on maps without ever really seeing. We tend to think of Earth as crowded, 8 billion of us. Cities lit up at night so brightly that from orbit the planet looks as though it has been threaded with veins of gold. Roads everywhere, lights everywhere, people everywhere. But if you look closely, Earth has its own lonely places, pockets where the human noise simply stops. There is an island in the South Atlantic Ocean called Tristan da Cunha. It is, by most measures, the most remote inhabited place on Earth. Roughly 250 people live there. The nearest other piece of land with people on it is over 1,500 miles away. There is no airport. There has never been one. The only way in is by ship, and the journey from South Africa takes about a week. The people who live there see the same faces every morning, walk the same single road, eat from the same small handful of crops. And yet even there, the loneliness has a limit. The wind carries voices, children laugh, boats arrive. There is always, somewhere within reach, the soft pressure of another human heart beating nearby. So we go further, down to Antarctica. There is a place there called the Pole of Inaccessibility. It is the point on the Antarctic continent that lies the farthest from any coastline. A flat, white, frozen nowhere, where the temperature can drop below -80 degrees Celsius, and the only sound for hundreds of miles is the slow movement of ice. No one lives there. No one ever has. The Soviets briefly built a station near it in the late 1950s. They left behind a small bust of Lenin, sticking up out of the snow, half buried, staring permanently at the southern sky. Decades later, expeditions still find that bust. The face of a man in a place where no faces are. That, you might think, is loneliness. A bust of Lenin, alone on the bottom of the world with no one to see him. But Earth has a place lonelier still. We have to leave the land entirely. In the South Pacific Ocean, far from any continent, there is a point on the water that has a name. It is called Point Nemo. It is the spot on Earth that is farthest from any land in any direction. The nearest dry ground is a small island called Ducie Island, more than 1,600 miles away. If you stood on the deck of a ship at Point Nemo and looked in every direction, you would see only water. The horizon, in every direction, ocean. And here is the strange detail. The nearest human beings to a ship at Point Nemo are not on any island or any continent. They are above. They are the astronauts of the International Space Station, drifting 250 miles overhead. The closest people to you in that empty patch of water are not on the planet. They are in the sky. Point Nemo is so empty, so unreachable, so far from anything else, that space agencies have given it a second, more haunting purpose. It is where we send our dead spacecraft. When the Russian space station Mir was brought down in 2001, it was guided to fall into Point Nemo. The International Space Station, when it is finally retired, will end its life there too. There is on the floor of the Pacific Ocean at Point Nemo a small, scattered graveyard of metal, pieces of stations, pieces of cargo ships, pieces of satellites, a quiet undersea cemetery for things that once flew. You can call that lonely if you like. It is the loneliest place on Earth that has a name, and yet it is still a place inside a hum. Even at Point Nemo, the wind carries oxygen we can breathe. The water below holds creatures we share a planet with. Storms move across the sky. Whales sing across thousands of miles of water and arrive at the hulls of passing ships. Earth, no matter how remote your patch of it, is busy. Earth is loud. Earth is connected. Even the loneliest place on this planet is, by any cosmic standard, deeply, intimately crowded. So we have to leave, pull yourself away from the surface, lift, slowly, gently upward, past the clouds, past the plains, past the highest weather, up into the place where the sky stops being blue and starts being black, up to where the International Space Station drifts. The astronauts there orbit Earth every 90 minutes. They see 16 sunrises a day. We sometimes think of them as the loneliest humans alive. They are not. They are, in some ways, the most accompanied. They live inside a small home shaped like a series of metal cans, with a few crewmates, with the planet always below them, with mission control on the radio at all hours, with letters and packages arriving from the surface every few months. Above them is the universe. Below them is everything they have ever known in a single round picture, no smaller than a dinner plate held at arm's length. They are not far from us. Not really. They are close enough to wave at if you knew where to look, so we go further still. Past the moon, past Mars, past the asteroid belt, past Jupiter and Saturn, past the icy worlds beyond Neptune, past the edge of what most people in their imaginations think of as the solar system, and out here in the dark we find something. A small, silver, suitcase-shaped object tumbling end over end through the vacuum, still somehow awake. Its name is Voyager 1. Voyager 1 was launched in 1977, the year of disco, the year of the first Star Wars film, the year before some of you were even born. It was sent originally to study Jupiter and Saturn. It did that, and then it kept going. It has never turned around. It has never slowed down. It is, right now, traveling at roughly 38,000 miles per hour in a straight line away from us, and has been moving at that speed for over 4 decades. As of tonight, Voyager 1 is about 16 billion miles from Earth. The exact number changes by the minute. To put that distance into something you can hold in your mind, think of it this way. Light is the fastest thing in our universe. A beam of light from your bedside lamp reaches the wall of your room in less than a billionth of a second. Light from the sun reaches the Earth in about 8 minutes. Light from the sun reaches Pluto in about 5.5 hours. And light, leaving Earth tonight at the speed of light, will take more than 23 hours to reach Voyager 1. In November of this year, 2026, that gap will close to exactly 24 hours. Voyager 1 will become the first object built by human hands to be 1 full light day away from us. A day, an entire rotation of our planet. That is how long it now takes our fastest possible whisper to reach our most distant child. And yet, somehow, Voyager is still talking to us. It has a power source about as strong as a household light bulb. Its memory is roughly 3 million times smaller than the phone in your pocket. Most of its instruments have been turned off, one by one over the years to save energy. But the radio still works. Once a day, a signal goes out from Earth. 23 hours and 32 minutes later, it arrives at the spacecraft. The spacecraft replies. Another 23 hours and 32 minutes pass. And then, here on the ground, in a small room full of engineers, the answer comes back. A conversation that takes 2 days for a single exchange. A friendship that stretches across a literal day of light. And here is where we have to be careful, because you might be tempted to say, surely, that this is loneliness. A small machine, 50 years out, surrounded by absolutely nothing, drifting alone in the dark, talking back to a world it cannot see. Surely Voyager 1 must be the loneliest thing in our universe, the most isolated object we have ever known. But that is profoundly wrong. And the reason it is wrong is important, because Voyager 1 is not really alone. Voyager 1 is still inside the family. It is still inside the sun's reach. Its trajectory is shaped by the gravity of our star, the gravity of the entire Milky Way, the slow tug of the galactic arms that swirl around us. It crossed into what we call interstellar space in 2012. Its instruments registered the change. The wind of particles streaming out from the sun, the solar wind, suddenly dropped away, and the colder, slower medium between the stars took over. By that one definition, yes, Voyager has left the solar system. But by a deeper definition, it has barely moved. Because the sun's gravitational influence does not end at the heliopause. It extends, gently but unmistakably, out to a vast spherical region called the Oort cloud, where trillions of comets drift in slow, ancient orbits. The outer edge of that cloud may lie nearly a light year from the sun. Voyager will not reach it for another 300 years. It will not pass through it for another 30,000. And only then, only after our hands have been dust for 1,000 generations, will Voyager 1 truly leave the gravitational reach of our star. So if you could ride on the back of Voyager 1 tonight, you would not be lonely. You would only be far. The sun would be smaller than a single bright star in your rear view, but it would still be the brightest thing in your sky. You would still be inside the solar system by any honest definition. You would still be home. You would simply be sitting in the very last room of a very large house, with the door slightly open, the porch light still on, the family still calling your name from down the hall. And this is the first lie we have to release tonight. The image of loneliness as distance, the image of the small figure in the dark surrounded by nothing. Voyager is far. Voyager is, by any human measure, unimaginably far, but Voyager is not lonely. Voyager is loved. Voyager is listened to. Voyager is, in a way, still being held. Real loneliness, the kind we are looking for tonight, is not measured in miles. It cannot be reached by simply traveling outward at 38,000 miles per hour for 50 years. It is something else, something stranger. Something that involves not just distance, but the slow, patient absence of any other thing to lean on. And that is where we have to go next. So before we leave this layer, sit for a moment with a question. Of all the places you have ever physically stood in your entire life, which one was the loneliest? The empty highway at 3 in the morning, the hotel room in a city where you knew no one, the hospital corridor in the middle of the night, the patch of forest where you suddenly realized you could not hear another human voice. Which moment, in your own small, precious history, comes closest to what you imagine loneliness looks like? Hold that memory, because in a few minutes, you are going to need it as a comparison. You are going to need it as the warm, familiar version of a word that, by the end of tonight, is going to be stretched into shapes you cannot yet picture. Because we are about to leave Voyager behind. We are about to pass that last whispered conversation. We are about to slip out of the family entirely, into the dark between the stars. And out there, in the spaces our spacecraft will never reach in any time that matters, we are going to find something the universe has been hiding from most of us. Worlds with no suns, planets that have never known a single sunrise, drifters the size of Jupiter moving alone through the black with no star to call their own. They are not science fiction. They are out there right now. There are billions of them, possibly trillions. And the James Webb Space Telescope has only just begun to find them. Let us go and meet a few, so we leave Voyager behind. We let that small, glinting machine drift on into the cold, knowing it will keep going long after we are gone, knowing it will keep talking back as long as its small heart still has a little warmth left in it. And we keep moving. We pass through the slow, distant shell of the Oort cloud. A vast, sparse sphere of icy bodies, leftovers from the birth of the solar system, drifting in orbits so wide and so slow that a single trip around the sun, for one of these comets, might take tens of millions of years. The Oort cloud is so spread out that, if you stood on one of its comets and looked around, you would see nothing but stars. The sun would be just one more pinprick of light among countless others. You would not be able to tell without measurement that you were still in our solar system at all, and yet somehow you would be. Held by an invisible thread of gravity, gently, patiently, pulled in a circle 1,000 times wider than Pluto's orbit, we pass beyond even that. We slip through the outer edge of our star's gentle reach, and now, for the first time tonight, we are truly between the stars. We are in what astronomers call the interstellar medium. The dust and gas and cold, thin matter that fills the space between every star in the galaxy. There is roughly 1 atom per cubic centimeter out here. By the standards of any laboratory on Earth, this is a perfect vacuum. By the standards of empty space, it is not empty enough. There are still atoms here. There are still particles. There is still, in the loosest possible sense, a fabric, but there are no suns, no planets visible to the naked eye, no worlds for billions upon billions of miles in any direction. The nearest star to our sun is Proxima Centauri, a small red dwarf in the Alpha Centauri system, just over 4 light-years away. 4 light-years sounds close. It is not. If the sun were a grain of sand in the middle of a football field, Proxima Centauri would be another grain of sand on the opposite end of that football field. Between them and the rest of the stadium, nothing. Just dark, cold air. Just the empty stands. Just the silence between 2 grains of sand. And here is where the universe finally begins to do something strange. Something most people have never been told. Out in this dark space between the stars, drifting slowly through nothing in particular, there are worlds. Not asteroids, not comets, not stones. Worlds, planets, some as large as Jupiter, with thick atmospheres and stormy weather and the slow internal heat that takes billions of years to bleed away into space. Some smaller, more rocky, with frozen surfaces and oceans of ice. Some perhaps Earth-sized, with hidden seas beneath their crust, kept just barely liquid by the warmth left over from their own formation. And they have no sun. Astronomers call them rogue planets, or free-floating planets, or, in their more poetic moments, simply drifters. They are worlds that do not orbit a star. They have no day. They have no night. They have no year because there is nothing for them to circle. They are simply out there, alone, moving in a slow and silent line through the dark space of the galaxy, with no light to warm them and no neighbor to keep them company. For a long time, we did not know they existed. The first hints came in the late 1990s, when astronomers started noticing strange, isolated objects in star-forming regions that did not fit any known category. They were too small to be stars. They were too lonely to be planets because planets, by every definition of the word at the time, had to orbit something. So what were they? Then came the James Webb Space Telescope. Webb sees in infrared light, heat light. It can pierce through the thick dust of nebulae, the cold curtains of gas that surround newborn stars, and reveal what is hiding inside. And what it found when it turned its gaze on certain stellar nurseries was extraordinary. In one survey of the Orion Nebula, a vast and famous cloud of gas and dust about 1,300 light-years away, the James Webb Space Telescope found more than 540 objects drifting through the inner regions of the nebula that were not stars. They were planets. Some of them roughly the mass of Jupiter, some of them smaller, some of them barely above the line that separates a planet from a failed star, all of them drifting freely, alone, with no sun to circle, in the dim light of the nebula's larger fires. And here is the detail that made astronomers stop in their tracks. About 9% of these objects were not entirely alone. They were in pairs. Two planet-sized worlds drifting through space together, slowly orbiting each other, with no star anywhere nearby. We had never seen anything like this before. Planets were supposed to come from stars. Planets were supposed to be the leftovers of star formation, the small cold things that condensed out of the disk of gas around a young sun. But these worlds had no sun. They had each other, and only each other. Astronomers gave them an unromantic acronym, JUMBO, Jupiter Mass Binary Objects. But that name does not do them justice. Imagine it. Two giant worlds alone together, slowly circling each other through the dark, perhaps for billions of years with nothing else around them. A planetary marriage in the middle of nowhere. The Webb telescope kept looking. It turned toward a smaller nursery called NGC 1333 in the constellation Perseus, about 960 light-years from Earth. And there it found 6 more young rogue planets. One of them, the smallest, had something extraordinary around it. A disk. A faint, rotating ring of dust and gas, like the kind that surrounds newborn stars, the kind from which planets themselves are born, around a rogue planet with no star. Astronomers realized slowly that this rogue world might be in the process of forming its own moons, or more astonishingly, its own miniature planetary system. A solar system without a sun. A family of worlds with a single drifting planet at its heart and nothing else. Let that sink in for a moment. Somewhere out there, around an object that has no star to call its own, the slow, patient process of building a planetary system is happening, with no light, with no warmth from outside. Just the dim glow of the parent world itself, leaking its leftover heat into the cold, and the quiet rotation of its dusty disk, slowly, condensing into worlds that will never know what a sunrise looks like. And these are the young ones. These are the rogue planets we can find because they are still warm, still glowing faintly in the infrared from the heat of their own birth. But most rogue planets are not young. Most are old. Most have long since cooled to temperatures so low that even Webb cannot easily see them. They are dark. They are silent. They drift through the galaxy at speeds of tens of thousands of miles per hour, on long, lonely paths that will not bring them near another star for millions, perhaps billions of years. How many of them are out there? We do not know exactly. But we are beginning to get an idea. In January of last year, 2025, an international team of astronomers published the most precise measurement we have ever made of a single rogue planet. The object had 2 clinical names, KMT 2024 BLG0792, also known as Ogle 2024 BLG0516. Forget the names, remember the object. It was a world about the size of Saturn, roughly 70 times the mass of Earth, drifting alone through the galaxy approximately 9,950 light-years from us, in the direction of the center of the Milky Way. It was detected through a technique called gravitational microlensing. As the rogue planet drifted in front of a distant background star, its gravity bent the star's light, briefly magnifying it, the way a magnifying glass bends sunlight. The flicker lasted only hours. But because two different observatories saw the same flicker from different angles, scientists could triangulate the planet's distance and its mass at the same time. It was the first time anyone had ever confirmed both for a true rogue world, and it was almost 10,000 light-years away, with no star anywhere near it. And here is the staggering implication. If you look up at the sky tonight and choose any random star in the Milky Way, statistically, there is a reasonable chance that somewhere between that star and our own sun, drifting through the empty dark, there is at least one rogue planet, possibly several, possibly many. The latest estimates suggest that the number of free-floating planets in our galaxy may equal the number of stars. Some astronomers go further. Some studies suggest there may be even more rogue planets than there are stars. Trillions of worlds drifting between the suns. A second, hidden population. A shadow galaxy of planets without stars, woven invisibly through the one we already know. Most of them we will never see. They are too small. They are too cold. They do not emit their own light except for a faint infrared glow that fades over the eons. They have no parent star to reflect from. They simply move, alone, through the dark, on trajectories carved out by ancient gravitational accidents that happened in the early universe. Imagine standing on one of them. Not one of the young, warm Jupiter-mass worlds, but an older, smaller rogue planet, somewhere out in the gap between stars. The sky above you would not be empty. It would be filled with stars. Possibly more stars than you have ever seen, because there is no atmosphere on most rogue worlds thick enough to scatter starlight into a glow. But none of those stars would be yours. None of them would rise. None of them would set. None of them would change in any way that mattered. They would simply be there, fixed, eternal, distant. The night would never end. The day would never come. The seasons would never turn. The world beneath your feet would have no idea, and no need to know, that other worlds existed. The only weather on most rogue planets would be the slow internal heat of the planet itself, bleeding outward over billions of years. Some of the larger rogue worlds, particularly those with thick atmospheres of hydrogen and helium, might still have storms. Slow, dark, lightning-shot weather, lit only by the planet's own dim glow. Some rocky rogue worlds may have subsurface oceans, kept liquid by the heat trapped beneath their frozen crusts. Astronomers have begun to seriously consider whether some rogue planets could, in theory, support life. Not on the surface. The surface would be far too cold, but beneath the ice, in hidden seas, in dark, warm water that has never been touched by starlight and never will be. Life that, if it exists, would have no concept of above, no concept of a sky, no concept of the rest of the universe at all. And just a few months ago, astronomers using the Very Large Telescope in Chile found something even stranger. A young rogue planet, about 620 light-years from us, that appears to be actively consuming gas and dust from its surroundings, growing at a rate of roughly 6 billion tons per second. A world without a star, slowly devouring the dark matter around it, getting larger and larger with no one to see, no one to know. A solitary giant feeding in silence. This is the first crack. This is where the familiar picture breaks. Because you were probably taught, somewhere along the way, that planets are things that belong to stars, that every world has a sun, that the structure of the universe is one of bright centers surrounded by dimmer companions, in tidy little arrangements like our own solar system. But that is profoundly wrong. The galaxy, our galaxy, is full of homeless worlds. They outnumber the stars. They drift between them. They have no place. They have no schedule. They have no calendar. They simply exist slowly in the dark, alone. And yet, and here is where we have to be careful again, even these worlds are not the loneliest things in the universe. Because every rogue planet, no matter how isolated it feels, is still inside the Milky Way. It is still moving with our galaxy, around the galaxy's center, in slow orbits that take hundreds of millions of years. It is still, however faintly, gravitationally tethered to the same vast spiral of stars that we are. It still rises and falls with the same wave of dark matter. It still belongs to the same family. It is far from any single star, yes, but it is not far from all of them. It is just one more thread in the immense, dark weave of our galaxy. A rogue planet is alone, but it is not exiled. There is a difference, and it is the difference between sitting in an empty room and being thrown out of the house entirely. So, before we go any further, sit with this for a moment. Somewhere in the galaxy tonight, possibly closer than the nearest star, there is at least one rogue planet. A world the size of Jupiter or Saturn or Neptune, or perhaps even Earth, drifting silently, frozen on the outside, possibly warm on the inside, possibly hiding an ocean, possibly hiding a kind of life we cannot even begin to imagine, with no star above it, no years, no days, just slow, patient motion through the dark on a path so long it will not change for millions of years. If you knew that for certain, would the thought of it haunt you, or would it somehow comfort you? Would you find it sad that a world like that exists, with no one to see its weather, no one to name its mountains, no one to ever set foot on it? Or would you find it strangely peaceful that the universe is patient enough and gentle enough to let such a world simply drift in the dark, undisturbed for as long as it likes? Sit with that question for a moment. There is no right answer. There is only your honest one, because we are about to leave even the rogue planets behind. We are about to go further still, because the universe, as it turns out, can do something stranger than simply make a world without a sun. The universe can do the reverse. The universe can take a sun, a full and burning star, with all of its planets gathered around it, and hurl it out of the galaxy itself, out into the immense, empty dark between galaxies, into spaces so wide that even our concept of between the stars no longer applies, into a kind of exile that the universe has only just begun to let us notice. So let us go and meet them, the exiles, the stars that no longer belong to any galaxy at all. To understand what we are about to see, you need to first hold something steady in your mind. The Milky Way, our galaxy, the vast spiral of roughly 200 to 400 billion stars that we live inside. It is not just a flat disk of suns. It is a dense, swirling structure bound together by gravity, held in place by an enormous halo of dark matter that surrounds it like a quiet, invisible ocean. Stars are born inside it. Stars live inside it. Stars die inside it. And almost every star you can see in the night sky, every single one of them belongs to this same galaxy. They are, in a very real sense, your neighbors. They share your address. They orbit the same center you do, in vast loops that take hundreds of millions of years to complete. The sun, the star that holds you up at this very moment, is one of them. Right now, as you sit and listen, our sun is moving around the center of the Milky Way at roughly 514,000 miles per hour. We do not feel it. We never have. The motion is too smooth, too steady, too vast for our small senses to detect. But we are moving, all of us, together, carried along in the same slow, immense rotation, with all the other stars around us, like a great procession of lanterns drifting in a long, slow river of darkness. Now, imagine for a moment that something interrupted that procession. Imagine that a star, somewhere in the Milky Way, was suddenly, violently flung out of the river, picked up by some invisible hand and thrown, hard, away from the others, faster than any star is supposed to move, faster than the galaxy itself can hold on to, fast enough that it would never come back, fast enough that, given enough time, it would leave the Milky Way entirely and sail into the vast intergalactic darkness, alone with nothing around it but the empty space between galaxies. That sounds like science fiction. It is not. It is happening. Right now. and it has been happening, slowly and steadily, for billions of years. The astronomers who first proposed this idea back in 1988 called these objects hypervelocity stars. Stars moving so fast that they have exceeded the escape velocity of the entire Milky Way galaxy. Stars that, no matter what happens next, are leaving forever. The first one was actually observed, against all odds, in 2005. Since then, astronomers have directly identified about 20 of them. Some are moving at speeds of over 1 million miles per hour. Some are moving even faster than that, approaching the unthinkable speed of 2.5 million miles per hour. To put that into something you can imagine, at those speeds, a hypervelocity star could cross the entire diameter of the Earth in roughly 30 seconds. They are the fastest stellar objects we have ever found, and we suspect there are thousands more. The 20 we have seen are just the ones we have happened to catch. The Milky Way is too vast, and our surveys are too incomplete to find them all. There may be many thousands of these fugitive stars, currently crossing through our galaxy on outbound trajectories, on their way to a permanent exile. But where do they come from? How does the universe accelerate something the size of a star to such impossible speeds? The leading theory involves a monster sitting at the very center of our galaxy. At the heart of the Milky Way, 26,000 light-years from where you are sitting, there is a supermassive black hole. It is called Sagittarius A star. It has a mass roughly 4 million times that of our Sun, all packed into a region smaller than the orbit of Mercury. It is not actively feeding right now. It is mostly quiet, but its gravity, even at rest, is extraordinary. And every so often, every 100,000 years or so on average, it does something cruel. A pair of stars wandering too close to Sagittarius A star will be torn apart, not destroyed, separated. The black hole's gravity captures one of them and pulls it down into a tight, doomed orbit where it will eventually be consumed. The other one, freed suddenly from its partner, is hurled outward at incredible speed. The slingshot effect is the result of pure gravitational physics. One star falls. The other flies, and the one that flies, if it is fast enough, leaves the galaxy entirely. This has been happening on and off for the entire age of the Milky Way. Roughly one star every 100,000 years. Multiply that out. Over the 13 billion years that our galaxy has existed, Sagittarius A star may have hurled more than 100,000 stars out into the intergalactic darkness, each one carrying, in some cases, its own planets, each one taking with it whatever solar system it had built up over its lifetime, each one beginning a journey that has no end. And here is the part that is hardest to picture. Those stars are still out there. The ones that were thrown out 1 billion years ago, 2 billion, 5 billion, 10 billion, they are not gone. They did not stop existing. They are simply gone from us. They are crossing the dark space between galaxies right now. Some of them are tens of thousands of light years above or below the disk of the Milky Way, sailing slowly into nothing in particular. Some of them are millions of light years away, beyond the reach of any of our telescopes, drifting toward galaxies they will never enter. Imagine, if you can, what one of those stars looks like today. A small red dwarf, perhaps, or a yellow star like our own Sun. Sailing alone through the immense space between galaxies. The Milky Way behind it would have shrunk to the size of a faint, fuzzy disk, smaller than the Moon as seen from Earth, no brighter than a small smudge in the sky. The next major galaxy, Andromeda, would be a similar pale smudge in the opposite direction. Around the exiled star, in every direction, there would be only emptiness. No close neighbors, no nebulae, no spiral arms, just the slow, lonely fire of one sun, burning steadily, surrounded by nothing. And here is the deeper layer. The stars that Sagittarius A star throws out are not the only intergalactic wanderers in the universe. They are simply the kind we know best. There is another, much larger population of orphan stars, scattered through every galaxy cluster in the universe, and we have only just begun to find them. For decades, astronomers suspected that something was hiding in the dark spaces between galaxies. There was always a faint, persistent glow there, a barely detectable smear of light in regions where there should have been nothing at all. In 2014, a team of astronomers led by Michael Zemkov at the California Institute of Technology, using an instrument called the Cosmic Infrared Background Experiment, made an extraordinary measurement. They studied that faint background glow more carefully than anyone had before, and they came to a conclusion that, even now, more than a decade later, still feels difficult to fully accept. As many as half of all the stars in the universe may live outside galaxies entirely. Half. Not a few, not some, not a small population of exiles. Half. If their estimate is correct, then for every star you see when you look up at the sky tonight, every star inside the Milky Way that has ever had a name or a number, there is another star. Somewhere out there drifting alone in the dark between galaxies with no galaxy of its own. These stars are called intergalactic stars, or more poetically, orphan stars. They are the children of ancient collisions. When two galaxies meet, the way Andromeda and the Milky Way will meet in about 4.5 billion years, the encounter is rarely violent in the way most people imagine. Galaxies do not crash into each other like cars. They drift into each other slowly, over hundreds of millions of years, their stars passing through one another almost untouched, while their immense halos of dark matter and gas merge and tear and reform. But during these encounters, individual stars sometimes get caught in unlucky places. They get flung outward by the changing gravitational fields. They get stripped from their home galaxies, like droplets of water flung from a turning wheel. They lose their grip and they sail away. We can see the evidence of this in nearby galaxy clusters. In the Virgo cluster, just 65 million light-years away, astronomers have detected individual red giant stars drifting alone in the spaces between the galaxies. Not part of any galaxy, not bound to any group of stars. Just single ancient suns sitting in the dark, left over from collisions that happened billions of years ago. In the Coma cluster, 300 million light-years away, the same thing. In the Fornax cluster, 62 million light-years away, the same again. Everywhere we look closely enough, we find them. The exiled. The orphans. The leftover stars of cosmic wars long since ended. Some of these intergalactic stars are very old. They were exiled before the sun was even born. They have been drifting in the dark between galaxies for 10 billion years or more. They have seen nothing change. They have crossed no boundary. They have simply burned slowly in the dark with their planets, if they still have any, circling them in absolute silence. And here is where I want you to slow down, because I want you to really try to picture this. Imagine a planet, an Earth-like planet, with oceans and continents, and weather and perhaps even something like life, orbiting one of these stars. A star that was thrown out of its home galaxy long, long ago. What does the night sky look like from such a world? There are no constellations, not in the way we have them. There are no other stars within easy view because every other star is hundreds of thousands or millions of light-years away. The galaxies, the ones that are visible at all, would be tiny smudges on the horizon. Pale, dim, fuzzy patches, no brighter than the dimmest star you have ever seen with your eyes. The sky would be, by our standards, almost entirely black. A creature on the surface of such a planet looking up at night would see only their own sun, slowly setting, and then absolute darkness. They would not see the Milky Way as a band of light, because there would be no Milky Way to see, only a distant smudge they might never even notice. They would not have a North Star. They would not have a Big Dipper. They would not have the stories we tell about the heroes and the animals in the sky, because there would be nothing to draw the lines between. Now, here is the question that should keep you awake. Would such a creature ever invent the word lonely? Loneliness, as we understand it, requires comparison. It requires the awareness that there is somewhere else, someone else, some other place that you are not in. A child on Earth feels lonely because they know other children exist and they are not with them. An astronaut on the moon would feel lonely because they know the Earth is back there, full of people, full of warmth. Loneliness is not just absence. It is the absence of something you know is missing. But a creature born on a planet around an intergalactic orphan star would have nothing to compare itself to. No bright sky to envy, no nearby suns to wonder about, no Milky Way to dream of. If their telescopes were good enough in time, they might discover the existence of distant galaxies. They might piece together, eventually, a picture of a universe of bright structures far away. But they would never see those structures as their home. They would never grieve them because they had never known them. They would simply be, quietly, in the dark, with one sun and one world and no one to call out to. Would they invent the word lonely, or would the word never even occur to them? You can hold that question for a while. Turn it over in your mind, because it tells you something important about what we are really looking for tonight. Loneliness is not just emptiness. It is the awareness of emptiness. It is something that only certain kinds of minds can feel. And the universe has spent the last 13 billion years making places where such awareness, if it existed, would have nothing to push against. Places where no one would ever know what they were missing. And yet, even an intergalactic star is not the loneliest thing in the universe. We still have further to go, because here is the thing about the space between galaxies. Even there, you are not truly alone. The galaxies, even when they are far apart, are still connected to each other. They are still part of the same vast structure. They are still tied together gravitationally by an immense, invisible scaffolding of matter that runs through the entire universe. We call it the cosmic web. It is a network of filaments and walls and clusters, stretched across the void in patterns that resemble, when mapped on a large enough scale, the neural pathways of a brain. The galaxies live on the threads of this web. The orphan stars live in the wider spaces, but still within reach of the threads. Even an exiled star, drifting through the intergalactic dark, is following currents of dark matter that link it, however faintly, to the rest of the cosmic structure. It is alone. But it is alone within a city, within a network, within a system that on the largest scales is still very much connected. But the cosmic web has holes in it. Vast, dark, empty regions where the web simply, almost completely, ends, where the threads do not reach, where the filaments thin out into nothing, where you can travel for hundreds of millions of light years and find almost no galaxies at all. There are galaxies, rare and strange galaxies, that have ended up sitting alone in these empty places. Galaxies that were either born in the void or somehow exiled into it long ago and have been drifting there ever since. They are not exiles within a city. They are entire cities by themselves in the middle of a desert larger than imagination. And so before we go there, sit with this thought. Somewhere right now, perhaps tens of millions of light years from here, perhaps further, there is a star. A single sun, burning quietly with no galaxy around it, possibly with a few planets in orbit, possibly with no one watching. Its night sky is almost entirely dark. Its days, if it has any worlds with surfaces, are lit only by itself. It has been drifting that way for billions of years. It will keep drifting in the same direction for billions more. If you were born on a planet around that star, your sky would be the simplest sky any conscious creature in the universe has ever seen. One sun, no others, the faintest possible smudge of a distant galaxy perhaps if you looked very hard, otherwise nothing. Would you ever invent the idea of loneliness? Or would you never know it was missing? And which one of those answers, honestly, sounds more peaceful to you? Hold that question, because we are about to take an even larger step. We are about to leave behind the idea of a single star, alone, and ask something stranger. What does it look like when an entire galaxy, with billions of stars of its own, finds itself in the same kind of isolation? What does it mean to be a city full of suns, sitting at the bottom of an empty desert, with no other cities for hundreds of millions of light years in any direction? We are going to meet such a galaxy. We are going to learn its name. And we are going to discover that by sitting where it sits, it tells us something profoundly unsettling about the universe we live in, and about what we are, by sheer cosmic luck, allowed to see. Before we go further, you need to understand something about how galaxies live. Because the picture in most people's heads is wrong, and tonight we have to gently correct it. When you think of galaxies, you probably picture them as solitary things. Bright spiral whirlpools floating in their own little corner of space, drifting alone through the dark like ships across an empty ocean. That is not how galaxies actually exist. Galaxies, almost all of them, live in groups. They have neighbors. They have families. They live gravitationally in long strings and clusters and walls of other galaxies, like beads on a necklace, like cities along a coastline. Most galaxies, when you look closely, are part of a community. Our own Milky Way is part of a community. We belong to what astronomers call the local group, a small cluster of about 80 galaxies, dominated by two large spirals, ourselves and Andromeda, with dozens of smaller dwarf galaxies orbiting around us like satellites. Andromeda, our nearest large neighbor, is only about 2.5 million light-years away. In cosmic terms, that is across the street. We can see her with our naked eyes on a dark night, a small faint smudge in the sky, the most distant thing the unaided human eye can detect. The local group itself sits within a larger structure called the Virgo supercluster, which sits within a still larger structure called the Laniakea supercluster, which contains roughly 100,000 galaxies in a vast, irregular blob of space about 500 million light-years across. We are deeply, intimately part of a neighborhood. When astronomers began in the 1970s and 1980s to map the universe in 3 dimensions, they expected to find galaxies sprinkled more or less evenly through space, like sand grains scattered across a table. They did not find that. What they found was something far stranger. The galaxies were arranged in a vast, intricate pattern. Long thread-like structures, called filaments, running for hundreds of millions of light-years across the universe. Dense knots, called clusters and superclusters, sitting at the intersections of these filaments, like cities where many roads meet. Broad, two-dimensional sheets, called walls, stretching across vast regions of space. And in between these threads and walls and clusters, vast empty regions where there were almost no galaxies at all. Voids. Enormous spherical or irregular pockets of nothing, hundreds of millions of light-years across, woven through the rest of the universe like the air pockets in a slice of bread. We call this whole structure the cosmic web. It is, on the largest scales, the actual shape of the universe. Not a smooth, even soup of matter, not a uniform fog of galaxies, but a sparse, vast, lacy network of threads and walls and clusters and voids, looking strangely like the neural pathways of a brain when seen from far enough away. It is the deepest map we have of what reality is built like, and if you ever wondered what the structure of everything actually looked like, that is it. A web, a vast, dark, glowing web. Galaxies, almost all of them, live on the threads of this web. They cluster along the filaments. They gather in the knots. They string themselves out along the walls. They follow the gravity of the structure they were born inside. They have neighbors because the cosmic web pulls them together. They are part of a network whether they like it or not. But here is the thing. The voids are not entirely empty. They are mostly empty. They are almost completely empty. But every so often, in a region where there should be nothing at all, astronomers find something extraordinary. A galaxy. A single, complete galaxy, sitting alone, with no companions for hundreds of millions of light years in any direction, drifting in the middle of a void as if it had been forgotten there, as if the cosmic web had failed to claim it. These are called void galaxies. There are not many of them. They are, by definition, rare. Most galaxies, the overwhelming majority, live in the threads, but a small handful scattered across the universe sit in the middle of the empty places. They are anomalies. They are oddities. And they tell us things about the universe that we cannot learn from any other kind of galaxy. One of them, in particular, has earned a name that the European Space Agency, in a rare moment of poetry, did not bother to soften. They simply called it what it is. The loneliest of galaxies. Its official designation, the one you would find in a catalog, is unromantic in the extreme. MCG plus 0102-015. It is a spiral galaxy. From a distance, it looks remarkably ordinary. If you saw a picture of it without knowing where it lived, you might think it was a perfectly normal galaxy, somewhere in a normal stretch of the cosmos, surrounded by the usual handful of neighbors. The Hubble Space Telescope took its portrait a number of years ago, and in that image, MCG plus 0102-015 looks beautiful. A delicate spiral with elegant arms wrapping around a bright central bulge, almost cocooning itself in its own light. Around it in the same picture you can see other galaxies, many of them, smaller, more distant smudges scattered across the dark background. But here is the cruel trick of the photograph. None of those smaller smudges are neighbors. None of them are companions. Every other galaxy in that image is hundreds of millions or even billions of light years behind MCG plus 0102-015. They are foreground stars from our own Milky Way and background galaxies sitting at impossibly larger distances. They are not friends. They are not nearby. They are simply happening to lie along the same line of sight as seen from Earth. The reality is this. If you flew to MCG plus 0102-015 tonight and stood on a hypothetical planet around one of its stars and looked up, you would see no other galaxies. Not nearby. Not in any direction that mattered. For roughly 100 million light years in every single direction, there would be no other galaxy. Not above, not below, not to the left or right, just emptiness. The galaxy itself, of course, would be full of stars. Hundreds of billions of stars, probably in its own spiral arms, with its own internal life and structure. But beyond that galaxy, nothing. A void. A vast spherical absence that swallows every direction you could possibly look. This galaxy lives in a region called the 0049 plus 05 void, which sits adjacent to a much larger underdense region called the Pisces void. Its loneliness is not an accident of nearby geography. It is not just temporarily isolated, with neighbors slightly out of view. It is genuinely, structurally alone. The cosmic web in the part of the universe where MCG plus 0102-015 exists simply does not run nearby. The threads of galaxies that would normally surround a spiral like it are far, far away. It is a city in the middle of a desert larger than imagination. Astronomers do not know for certain how it got there. There are two competing theories, and both of them are haunting. The first theory is that it was born there. Imagine, in the very early universe, billions of years ago, a small region of slightly higher density forming in the middle of what would otherwise become a void. A pocket of matter, against the odds, condensing into a single galaxy in a place where there were no other companions. The galaxy formed in solitude. It has been alone its entire life. It has never had neighbors. It has never been close to another galaxy. It has simply existed, quietly, in the middle of an absence that the universe never bothered to fill in. If this is true, then MCG plus 0102-015 015 has been the loneliest of galaxies for the entire span of its existence, possibly 12 billion years of complete isolation. Possibly 12 billion years of stars being born and dying inside it, with no other galaxy to witness any of it. The second theory is darker. It is that, long ago, MCG plus 01, 02, 015 was once part of a community. It had neighbors. It had a family. And then, in some ancient gravitational interaction, perhaps a near collision with another galaxy or a gravitational kick from a passing cluster, it was thrown out of its home, out of its filament, out into the void. And ever since, for billions of years, it has been drifting alone, slowly moving through empty space with the rest of its family forever beyond its reach. An exiled city, a banished spiral. We do not know which of these stories is true. We may never know. But here is what we do know, and what is, in a way, even more unsettling than either of the two theories. The implication of where MCG plus 01, 02, 015 lives changes our understanding of what science even is. And it does so through a single, devastating thought experiment that an astronomer named Greg Aldering once put forward. The thought experiment is this. What if our own galaxy, the Milky Way, had been born in the same kind of void that MCG plus 01, 02, 015 lives in? What if, instead of forming in a busy, filament-rich part of the cosmic web, with Andromeda nearby and a whole local group around us, we had formed in the middle of a void, with no other galaxies for 100 million light-years in any direction? How would the history of human astronomy have unfolded? The answer is unsettling. According to NASA's own account of the void, if the Milky Way were placed where this lonely galaxy sits, we would not have known that other galaxies existed until sometime in the 1960s. Think about that for a moment. Let it sit. In our actual history, we discovered that other galaxies existed in 1923. That was when Edwin Hubble, using the new 100-inch telescope at Mount Wilson Observatory in California, looked carefully at a faint fuzzy patch in the sky called the Andromeda Nebula and realized slowly that it was not a nebula at all. It was a separate galaxy, similar to our own, 2.5 million light-years away. He had effectively redrawn the entire universe in one observation. Before that night, the human species believed that the Milky Way was, more or less, all there was. That every star in the sky was inside our own galaxy. That the smudges and patches we saw between the stars were just clouds of gas. After that night, we understood for the first time that our galaxy was just one of many. That the universe was vastly, almost incomprehensibly, larger than we had ever guessed. That the night sky was not the universe. The night sky was just one room in it. But Edwin Hubble was only able to make that discovery because there was another galaxy, Andromeda, close enough to see. 2.5 million light-years is, in cosmic terms, almost touching. With a 100-inch telescope in 1923, he could just barely resolve the individual stars inside Andromeda, just barely measure their distances, just barely confirm that they were not part of our own Milky Way. He had a target. He had something to study. He had a galaxy across the street. Now imagine that the nearest galaxy to us was not 2.5 million light-years away, but 100 million, 40 times farther. Andromeda, at 100 million light-years, would be a smudge so faint that no telescope on Earth in 1923 could have detected it. No telescope on Earth for decades to come could have detected it. Hubble would have looked at the sky and seen nothing but stars. He would have measured, he would have cataloged, he would have searched for the faint fuzzy patches that had so excited the previous generation of astronomers, and he would have found nothing. The smudges would not have been there. The galaxies would have been too far to see. The universe to him would have appeared to consist of one single galaxy, ours, and nothing else. He would have died believing that. So would everyone who came after him for decades. Until, sometime in the 1960s, telescopes might have finally become powerful enough to detect the faintest, most distant galaxies at 100 million light-years out. And only then, would humanity have suddenly realized that there were others, that we were not alone, that the universe was, in fact, much bigger than our own single spiral. This is what is so haunting about MCG plus 0102015. Its location does not just make it lonely. It tells us that loneliness for an entire civilization is possible. That if you were born in the wrong place in the cosmic web, you might spend your entire existence as a species believing that your galaxy was the universe. You would not feel deprived. You would not feel cut off. You would simply think that what you saw was everything there was. You would write your philosophies and your religions and your sciences around the assumption that one galaxy was all of reality, and you would never know what you were missing. Because there would be nothing, until perhaps very late in your civilization's life, to even hint that anything was missing at all. The history of cosmology as we know it may be a luxury of our particular cosmic address. The fact that we know the universe is vast, that we know there are galaxies beyond ours, that we know about the Big Bang, that we know about expansion, that we know about anything beyond our own pale blue dot, may be the gift of having been born in a busy neighborhood. The local group is not particularly special by cosmic standards. It is just one of many groups on one of many filaments in the cosmic web. But it is enough. It is enough to have other galaxies close enough to see. It is enough to have given us a hint, a clue, a smudge in the sky that there was more. A civilization in the middle of the 0049 plus 05 void, if such a civilization exists, would have no such clue. They would look up. They would see their own galaxy in all its glory. They would see the stars of their own galaxy in all their beauty, and they would see, beyond that, nothing. They would invent astronomy. They would build telescopes. They would catalog the planets around their own sun. They would map the spiral arms of their own galaxy, and they would, perhaps, conclude that they were alone, that this was the cosmos, that nothing else existed, and they would not be wrong by any evidence available to them. They would simply be blind by the geography of their birth to a truth that we, by sheer luck, were given. Sit with this for a long moment, because it changes something about how you should think about the universe. We did not just get lucky to exist. We did not just get lucky to be on a planet in the habitable zone of a stable star. We got lucky to be in a place where the cosmos is still visible. We got lucky to be inside the web, where neighbors are close enough to see. We got lucky to be where a civilization could, eventually, look up and figure out the truth. If humanity had been born in the loneliest of galaxies, we would have spent every generation of our existence, every philosophy, every religion, every science, every dream, building our entire worldview around a single spiral of stars, never knowing that the universe was in fact mostly other galaxies stretching beyond imagination in every direction. Our science would be smaller. Our myths would be smaller. Our sense of where we stood in the universe would be, by definition, smaller. So before we leave this layer, hold this question close. If humanity had been born in a void galaxy, never seeing another galaxy, never suspecting the universe was bigger than our own single spiral, would we still ask the same questions about meaning and origin and purpose that we ask now? Or would those questions never even occur to us, because we would have no idea that there was anywhere else to wonder about? Would we feel smaller or larger in such a place? Would the night sky feel like a comfort, with one beautiful galaxy gently glowing above us, or would it feel like a strange and unspeakable absence, with everything we did not know hidden behind a vast, silent, impossible distance? There is no right answer. There is only your honest one. Hold it close, because we are not done. We have, in a sense, only just begun. because MCG plus 0102015 is the loneliest of galaxies, but it is still a galaxy. It is still a city. It is still a structure with hundreds of billions of stars in it. And the void it sits in, the empty desert around it, is itself only one of many such deserts in the universe. There is one, in particular, that is so vast, so deep, so almost completely empty, that it makes the loneliness of a single void galaxy look like a small detail. A region of space so empty that, when astronomers first noticed it in 1981, they were not sure they could believe their own data. A region called Boötes, a region that has, for the last 45 years, carried a second, more haunting name, the Great Nothing. That is where we go next. In 1981, a young American astronomer named Robert Kirshner, working with 3 colleagues, was doing what he believed was a fairly routine survey of the sky. He was measuring the redshifts of galaxies. Redshift, very briefly, is the stretching of light from a distant object caused by the expansion of the universe. The further away a galaxy is, the faster it appears to be moving away from us, and the more its light gets stretched toward the red end of the spectrum. By measuring redshifts carefully, you can build a 3-dimensional map of the universe. You can figure out where the galaxies are. You can see, slowly, the shape of the cosmic web emerging from the data. Kirshner and his team were not looking for anything dramatic. They were just mapping. They were filling in a piece of the cosmic atlas. They were doing the slow, careful work that science requires. And then, in their data, they saw something that should not have been there. A gap. A vast, empty region in the sky in the direction of the constellation Boötes. The herdsman, the figure in the northern sky who drives the Great Bear, Ursa Major, around the pole of the heavens for all eternity. In that direction, at a distance of roughly 700 million light-years from Earth, there should have been galaxies, thousands of them. The cosmic web should have been thick there. Filaments should have run through it. Clusters should have dotted its edges. The map should have been crowded. It was not crowded. It was almost entirely empty. The team checked their data. They checked it again. They went back to the telescopes and looked more carefully. The gap was still there. A vast, spherical, almost completely empty region of space, hundreds of millions of light-years across, with almost no galaxies in it at all. When they finally published the discovery in 1981, they were cautious. They did not call it a void. They did not call it the Great Nothing. They simply reported a remarkable, statistically significant absence of galaxies in a region of space larger than anything previously catalogued. The full confirmation came 6 years later, in 1987, when the survey expanded, and the gap, instead of filling in, only grew deeper and more clearly defined. The astronomy community had to give it a name. They called it the Boötes Void after the constellation it lay behind. Some, more poetically, called it the Great Nothing. Some still call it that today. Here are the numbers. Try to hold them in your mind. The Boötes Void is roughly spherical. Its diameter is about 330 million light-years. That is, by itself, a number too large for any human mind to truly hold. So let us anchor it. The Milky Way galaxy, our home, is about 100,000 light-years across. The Boötes Void, end to end, is more than 3,000 times the diameter of the Milky Way. You could line up 3,000 Milky Ways, edge to edge, and you would just barely cross the void. Or, to put it another way, the entire local group of galaxies, the 80-galaxy community that includes the Milky Way and Andromeda and all our smaller satellites, is about 10 million light-years across. The Boötes Void is 33 times wider than that. You could fit dozens of local groups, side by side, inside the empty space of the Boötes Void, with room left over. The center of the void is about 700 million light-years from Earth. By the standards of how galaxies are normally distributed in the universe, the Boötes Void should contain roughly 2,000 galaxies. That is the average expected density of galaxies in a region that size. 2,000 spiral and elliptical and irregular galaxies, scattered along the filaments and clusters of the cosmic web, going about their slow lives, the same way the galaxies in our own local group go about theirs. It contains roughly 60 out of 2,000, in a region more than 300 million light-years across. The Boötes void is missing, conservatively, about 97% of the galaxies it should have. It is not just underpopulated, it is almost catastrophically empty. It is the closest thing to nothing that we have ever found at that scale in the entire observable universe. The handful of galaxies that do live inside the Boötes void are themselves something extraordinary. They are scattered sparsely across that vast desert. Many of them are small, faint dwarf galaxies, the cosmic equivalent of small, lonely villages. A few are larger spirals, each one like MCG plus 01, 02, 015 in its own smaller void, lives in profound isolation from the others. The nearest galaxy to most of them is often tens of millions of light-years away. Some of these void galaxies, when astronomers study them, show signs that they are different from galaxies in the cosmic web. They tend to be bluer, younger-looking, with high rates of new star formation. They have evolved more slowly in some ways because they have never had close neighbors to disturb them, no near collisions, no gravitational interactions, no merging or stripping. They are like quiet villages on a frontier, undisturbed by history, doing their own slow business, with no roads to anywhere. And the Boötes void, as massive as it is not the only one. It is just one of the most famous. The cosmic web is honeycombed with voids like it. There is something called the Eridanus supervoid in the southern sky. It is even larger than Boötes, possibly stretching close to 1.5 billion light-years across in its longest dimension. It sits at a slightly closer distance, somewhere around 2 billion light-years away, and it sits directly behind one of the most puzzling features in modern cosmology. The cosmic microwave background, the faint afterglow of the Big Bang that fills the entire sky in microwave light, has a cold spot, a region of sky in the direction of the constellation Eridanus that is noticeably colder than the surrounding background. For decades, astronomers debated what could be causing it. Was it a statistical fluke? Was it evidence of some exotic physics in the early universe? Was it, as some speculated, the imprint of another universe gently brushing against our own? The answer, slowly, has begun to emerge. The Eridanus supervoid is so vast, so empty, so dramatically underdense, that it appears to be cooling the cosmic microwave background light that passes through it. As light from the Big Bang crosses through the void, it loses a tiny amount of energy due to the expansion of the universe and the gravitational physics of underdense regions. The result is a faint cooling of the light, observable from Earth, that we see as the cold spot. It is, in other words, possibly the largest known cold place in the observable universe, a region so empty and so vast that we can see its shadow in the oldest light we know how to detect. And then there is the deepest reframe of all, the one that should genuinely change how you feel about the night sky. There is growing evidence that our own galaxy, the Milky Way, sits inside a void. This idea is called the KBC void, named after three astronomers, Ryan Keenan, Amy Barger, and Lennox Cowie, who studied it in 2013. It is also sometimes called the local hole. It is, if it exists at its full proposed size, roughly 2 billion light-years across. The Milky Way sits within a few hundred million light-years of its center. Let that settle for a moment. We may live, right now, in a region of space that is roughly 20 to 30% less dense than the average region of the universe. Not as empty as the Boötes void, not as deep as the Eridanus supervoid, but underdense, quieter, sparser. Our entire cosmic neighborhood, our local group, our Laniakea supercluster, the entire visible sky as we have ever mapped it, may be sitting inside a vast, gentle, billion light-year wide region of below-average matter, a void within which we have been living the whole time. A void within which we built our science, wrote our philosophies, fell in love, raised our children, and looked up at the stars and thought we knew what we were looking at. This idea remains controversial. Not every astronomer is convinced. The KBC void, if it is real at its full proposed size, would be larger than the standard cosmological model predicts should be possible. Some studies argue it exists as described. Some studies argue that, while there may be a local underdensity, it is smaller and shallower than the original proposal suggested. The debate is ongoing. New surveys, like the Dark Energy Spectroscopic Instrument, known as DAISY, and the European Space Agency's Euclid mission, are mapping the local universe in unprecedented detail. And over the next few years, we may finally know for sure whether we are sitting inside the largest void anyone has ever proposed. But even the more conservative estimates agree on one thing. The local universe around the Milky Way is significantly emptier than the cosmic average. The cosmic web near us is thinner than it should be. The neighborhood we live in is, by the standards of the universe, comparatively quiet, comparatively sparse, comparatively void-like. This may even explain one of the strangest puzzles in modern cosmology. For decades, two different methods of measuring how fast the universe is expanding have given two stubbornly different answers. The method that uses nearby stars and supernovae gives one value. The method that uses the cosmic microwave background, the oldest light in the universe, gives another. The disagreement is small in absolute terms, but it is large enough that astronomers cannot reconcile it. It is called the Hubble tension. And one of the leading explanations is simply that we live in a void. That because the local region around us is slightly underdense, matter is gravitationally flowing outward toward the denser regions beyond us, making it look, to our instruments, as if the universe is expanding faster than it really is on average. Our local emptiness is biasing our measurements. The void around us is fooling our calculations. If this turns out to be correct, then we are not just lonely cosmic observers in a friendly neighborhood. We are lonely cosmic observers in a comparatively empty corner of a vast, mostly empty universe. We may be sitting in a region where there is, by cosmic standards, less of everything. Fewer galaxies, fewer clusters, less gravitational structure, fewer companions in every direction we can look. The Milky Way is not in the middle of a great cosmic city. It may be in something closer to a vast, gently empty plain. So step back for a moment. Try to see the picture as a whole. The universe on the largest scales is mostly emptiness. Astronomers now estimate that voids occupy roughly 80% of the volume of the observable universe. 80%. 4 out of every 5 cubic light-years of space, on average, is essentially empty. Galaxies are not the rule. Galaxies are the exception. The cosmic web is not a structure draped across mostly full space. The cosmic web is a thin, delicate lacework of light strung across mostly empty halls. We have it backwards in our intuitions. We picture the universe as space dotted with galaxies. We should picture it as galaxies dotted with vast, almost incomprehensible voids in between. And here, finally, is the reframe. This is where the question of the loneliest place starts to dissolve into something stranger than we expected. Because if 80% of the universe is voids, then the loneliest place in the universe is not a single special location. It is, on the contrary, the most common kind of place. The deep, empty interior of a cosmic void is not a rare destination. It is the default condition of most of the volume of reality. The rarity on cosmic scales is the company. The rarity is the galaxy, the cluster, the filament. The rarity is having neighbors at all. The rarity is what we have here on Earth in our local group, inside our familiar little spiral. The exception, statistically, is not loneliness. The exception is us. If you picked a random point in the observable universe and dropped yourself there, you would, in 8 out of 10 cases, find yourself in the middle of a void, drifting in a vast region of almost nothing, with the nearest galaxy possibly hundreds of millions of light years away. The sky around you would be black, truly black, not the black of Earth's night sky, which is filled with stars and the soft glow of the Milky Way and the distant smudges of nearby galaxies. The black of a cosmic void is something else. It is the absence of nearby light entirely. If your eyes were sensitive enough to see the cosmic microwave background, you would notice the faint, almost uniform glow of the Big Bang itself, ancient light from every direction, the way an old room is dimly lit by a single bulb at evening. But of bright objects, of nearby stars, of close galaxies, you would see nothing. Just the great soft glow of the universe's afterbirth, and beyond that, distant smudges of galaxy clusters at the edges of the void, hundreds of millions of light years away, no brighter than the faintest stars in the human sky. That is, statistically, what most of the universe looks like. That is the default view, so our concept of the loneliest place in the universe has to shift. It is not a single dramatic location. It is, in some sense, almost everywhere. Loneliness on cosmic scales is the rule. We are the strange ones. We are the lucky ones. We are the rare little spiral in the rare little neighborhood, in a thin, faintly underdense region of the cosmic web, surrounded by other galaxies that are close enough to see and far enough to study. We were given a gift we did not earn. We were given neighbors. And yet, even now, even with this reframe, we are not at the deepest answer, because there is still one more layer to peel back. The voids, as empty as they are not totally empty. They have shapes, they have boundaries. They have edges where the filaments of the cosmic web pass by. Even the deepest voids have, somewhere in them, a few stray galaxies like the lonely spiral we met in the last layer. They have structure. They have geometry. The cosmic web, in some sense, still touches them, at the rim. But what happens when even that thin lacework of structure is gone? What happens when the universe expands so much, over time, that even the galaxies that are now visible to each other drift apart so far that no light can connect them? What happens when the cosmic web itself begins to dissolve, not because anything has been destroyed, but because everything has been carried by the slow, accelerating expansion of space beyond the reach of everything else? That is where we go next, and it is the final move. Because the answer to the question of the loneliest place in the universe, as we are about to see, is not a place. It is a moment. It is a time. And the strangest thing about it, the most haunting thing about it, the most quietly devastating thing about it is that it is coming. Slowly, patiently, inevitably. It is coming for everything, for every galaxy, for every star, for every world, for us. But before we go there, sit for a moment with this question. If you learned tonight that our own Milky Way sits inside a vast cosmic void possibly 2 billion light years across, that the home you have always thought of as a busy, crowded part of the universe is in fact one of the emptier neighborhoods in the cosmos, would knowing that change how you feel when you next look up at the night sky? Would you feel smaller? Would you feel more precious? Would you feel that the stars above you, the ones you have known since childhood, suddenly mean something a little different, knowing that beyond them in every direction there is more emptiness than you ever realized? There is no right answer. There is only your honest one. Hold it. Because we are about to take the final step, and it is the strangest one of all. There is a force in the universe that we still do not fully understand. We have given it a name. We call it dark energy. The name is, in a way, a confession of ignorance. We do not know what it is. We do not know where it comes from. We do not know why it has the strength it has instead of being stronger or weaker. We only know what it does. And what it does is quietly, patiently, terrifying. Dark energy makes the universe expand. Not just expand, the way Edwin Hubble first discovered in 1929, when he realized that distant galaxies were moving away from us. That kind of expansion by itself would have been slowing down over time, gradually pulled back by the collective gravity of all the matter in the cosmos. That is what we expected to find. That is what Einstein expected to find. That is what every astronomer, deep in their bones, expected to find. A universe that was expanding, yes, but expanding more slowly with each passing billion years as gravity quietly applied its brakes. In 1998, two independent teams of astronomers studying distant exploding stars called Type Ia supernovae discovered something that no one had predicted. The expansion of the universe was not slowing down. It was speeding up. The galaxies were moving apart faster today than they were a billion years ago. Faster a billion years ago than 2 billion years ago. Faster 2 billion years ago than 3. Something was pushing them. Something was overcoming gravity. Something was, gently and steadily, accelerating the entire universe outward. That something is what we call dark energy. It appears to make up roughly 68% of the total energy content of the cosmos. Dark matter, the invisible substance that holds galaxies together gravitationally, accounts for about 27%. Everything else, every star and planet and gas cloud and human being and idea that has ever existed, makes up less than 5% of the universe. We are, in terms of substance, a rounding error. The cosmos is mostly something we cannot see, pushing the rest of itself apart. Dark energy has been doing this for the past 6 billion years or so. For the first 8 billion years of cosmic history, gravity was strong enough to keep things mostly in check. Matter was clumping together. Galaxies were forming. The cosmic web was being woven into the shape we now see. Then, somewhere between 5 and 7 billion years after the Big Bang, dark energy began to win. It has been winning ever since, and it will keep winning slowly, patiently, for the rest of time. Here is what that means for the future. Right now, when we look out at the universe with our telescopes, we can see roughly 2 trillion galaxies. They are arranged across the cosmic web in vast clusters and filaments and walls. They are far apart, but they are visible. Their light reaches us. Their stars twinkle faintly in the deep images of the Hubble Space Telescope and the James Webb Space Telescope. We can study them. We can map them. We can tell the story of how the universe came to look the way it does. But all of those galaxies are moving away from us, not because they are flying through space in our direction, because space itself between us and them is expanding. The further away a galaxy is, the faster it appears to recede, and dark energy means this recession is speeding up. Slowly but inevitably, more and more distant galaxies are being carried away from us at greater and greater speeds. Eventually, they will be receding so quickly that their light can no longer keep up. They will pass through what is called the cosmic event horizon, and after that, no signal from them will ever reach us again. They will not be destroyed. They will still be there, somewhere out in the dark, doing whatever galaxies do, but to us, they will be gone, forever. Permanently invisible, as though they had never existed. This has already begun. There are galaxies right now whose light is on its way to us, but whose more recent light, the light they are emitting today, will never reach us. We are seeing those galaxies as they were billions of years ago. We will never see them as they are now. We will see them slowly fade and redshift further and further into invisibility, over hundreds of billions of years, until they vanish from our skies entirely. In about 150 billion years, the only galaxies still visible from where the Milky Way sits will be those of our own local group. Every other galaxy in the universe, including the ones we currently see in our most powerful telescopes, will have receded beyond observability. The night sky for any civilization that exists at that time will look very different from ours. They will look up and see a single, vast galaxy, because by then, the Milky Way and Andromeda will have finished doing what they have already started to do. They are currently moving toward each other at about 250,000 miles per hour. In about 4.5 billion years, they will begin to merge. Over the following billion years or so, the two great spirals will tear each other apart and reweave themselves into a single, larger galaxy. Astronomers have given that future galaxy a name. They call it Milkomeda, a blending of Milky Way and Andromeda. A single elliptical structure where two spirals used to be. Milkomeda will live on for many billions of years. The stars within it will continue to form, age, and die. But beyond it, the rest of the universe will slowly disappear. By 150 billion years from now, any astronomer who looks up from a planet inside Milkomeda will see only their own galaxy. No Andromeda, because Andromeda will be part of them. No other galaxies in the distance. No smudges. No fuzzy patches. Just one immense galaxy of stars, surrounded by an apparently empty universe, with nothing else to be seen. That civilization, if it exists, will know nothing of what we know. They will not be able to see the Big Bang's afterglow. They will not be able to detect other galaxies. They will not be able to measure the expansion of the universe, because there will be nothing far enough away to measure it against. They will look up and see a single galaxy surrounded by black, and they will conclude reasonably that this is the universe. That the cosmos is a single island of stars in an infinite empty void. They will be wrong. They will not be able to know they are wrong. They will write their cosmologies around what they can see, and what they can see will tell them they are alone. Our generation, in other words, lives in a privileged moment. We can still see the rest of the cosmos. We can still detect the cosmic microwave background. We can still map 2 trillion galaxies. We can still tell the story of the Big Bang and dark energy and expansion. In the very deep future, none of that will be possible. The evidence will have receded beyond reach. The truth will still be there, but the truth will be unreachable. The far future astronomers of Milkomeda will believe in a smaller, simpler, lonelier universe, and they will have no way to know better. And this is only the beginning of what dark energy does to the cosmos. Let us keep going forward in time, past 150 billion years, past a trillion. Inside Milkomeda, the stars continue to live and die. New stars form from the gas that remains. Old stars run out of fuel and fade, or explode, or quietly collapse into white dwarfs and neutron stars and black holes. The galaxy grows older. The bright young blue stars are the first to go, because they burn through their fuel quickest. Then the middle-aged yellow stars, like our sun, slowly become red giants and then small white dwarfs. Then the small red dwarfs, which burn the slowest and live the longest, begin to flicker and dim. And at some point, somewhere around 100 trillion years from now, the very last star in Milkomeda forms from the very last cloud of gas, burns brightly for as long as it can, and then begins to fade. After that, no new stars will form anywhere, ever. The cosmos will run out of the fuel needed to make them. The era of star formation, the era that has dominated the universe for the past 13 billion years, will quietly end. There will still be stars burning, the last small red dwarfs taking their time. But no new ones will be born. The universe will, in a sense, go from being a story about birth to being a story about slow dying. This is called the stelliferous era, the time of stars. We live near the beginning of it. The middle of it has not yet been reached. The end of it lies 100 trillion years in our future. It is, in cosmic terms, a brief, brilliant chapter, a flash of light in the middle of a much longer darkness. After the stelliferous era comes the degenerate era. It will last for an unimaginable span of time, trillions, then quadrillions, then quintillions of years. During the degenerate era, the only stars left will be the remnants of dead stars, white dwarfs slowly cooling, neutron stars sitting silently, black holes drifting through nearly empty galaxies. The galaxies themselves will have begun to dissolve. The orbits of their stars will gradually be disrupted by gravitational encounters, and stars will, one by one, drift out of the galaxies entirely into the deepening dark between them. Some will fall into the central black holes of their galaxies and be consumed. Others will simply escape into the void, becoming the ultimate orphans, drifting alone in the slowly expanding universe. Eventually, even the dead stars will fade. White dwarfs cool down. After enough time, they become so cold and dim that they are essentially invisible. Neutron stars cool too. Black holes slowly, over almost incomprehensible spans of time, evaporate by emitting what is called Hawking radiation, gradually losing mass to the universe until they vanish entirely. The largest black holes will take so long to evaporate that the numbers become almost meaningless. A black hole with the mass of a galaxy might take 10 to the 100th power years to disappear. That is a 1 followed by 100 zeros. The age of the universe right now is about 10 to the 10th power years. Take that number, 10 to the 10th, and raise it to the 10th power. Then do that again, and you are only beginning to approach the timescales we are talking about. After all of this, after every star has died, after every black hole has evaporated, after every structure has dissolved, the universe will enter what is called the dark era. The dark era has no end. It simply goes on, forever. By that point, the universe will have expanded so much, and dark energy will have done so much work, that every region of space will be effectively isolated from every other region. There will be no galaxies. There will be no stars. There will be no clusters or filaments or walls or voids. The cosmic web will have completely dissolved. Every cubic light year of space will be, on average, identical to every other cubic light year. Cold, empty, filled with nothing but a faint scattering of fundamental particles, drifting at random with no structure to give them shape. The universe will become a uniform, eternal, expanding emptiness. We call this the heat death. The name is misleading. There is no heat involved. It is the opposite. The heat death is the end of meaningful temperature difference. The universe will be, on the largest scales, a single, infinite, almost perfectly uniform expanse of barely warm nothing. Photons, drifting forever. A few neutrinos. Some scattered particles too far from any others to ever interact again. The cosmos will not be destroyed. It will not collapse. It will simply settle into a slow, infinite, perfect, eternal sameness. Hold this in your mind. Try, just for a moment, to feel it. In the heat death, every place in the universe is the loneliest place in the universe. Not because any one location is special, but because all locations have become equivalent, empty, identical, with nothing nearby, nothing far away, nothing anywhere. The concept of loneliest loses its meaning because there is no longer a less lonely to compare it to. There is just emptiness eternally. There is just isolation everywhere. This is the final answer. This is the deepest layer. The loneliest place in the universe is not a single location. It is not a void galaxy. It is not the deep interior of the Boötes void. It is not even the empty space between galaxies that have receded beyond all observation. The loneliest place in the universe is the universe itself, in its far future, after everything has cooled, after everything has evaporated, after everything has drifted irretrievably apart. The loneliest place is not where. The loneliest place is when. And now we have to do something difficult. We have to turn around. Because the second half of this realization is, somehow, even stranger than the first. If the loneliest place in the universe is the far future, then it follows, in a way that is almost too beautiful to bear, that you, right now, are not in it. You are not in the heat death. You are nowhere near it. You are sitting, listening in the middle of what may be the most companioned moment in cosmic history. Right now, this very evening, the universe is still full of structure. Stars are still being born. Galaxies are still merging. The cosmic web still glows. 2 trillion other galaxies still send their ancient light toward us, and our telescopes still catch it. Andromeda is still close enough to see with your unaided eye. The Milky Way still curls overhead on a dark night, a great river of stars, a billion neighbors that you can step outside and see. You happen to exist in a brief, brilliant window. The lamps are still on. The universe is still full of itself. The cosmos is still saying in every direction you can look that you are not alone. There are other suns, there are other worlds, there are other galaxies, there are perhaps other minds. This window will not last forever. In 1 trillion years, all of that will be gone. In 100 trillion years, the last star will be cooling. In timescales that we have no real names for, even the dust will have settled into nothing. But right now, you are here while the lights are still on. You are here while the night sky still has something in it. There is a strange, quiet gratitude in that. We did not get to choose when to exist. We did not get to pick our cosmic era. We could have been born in the far future, in a Mokomata that sees no other galaxies, and we would have spent our entire civilization believing the universe was smaller and emptier and lonelier than it really is. We could have been born even later, in the degenerate era, around a slowly fading dwarf star, with no neighbors visible anywhere, with no way to know the story of where we came from. We could have been born in the dark era, except there will be no one to be born in the dark era. There will be no possibility of life by then. There will be no possibility of anything. We are here now. We are here while the cosmos is still rich. We are here while the stars still burn. We are here while there are still other places to wonder about, still other galaxies to study, still a Milky Way to look up at on a clear night and feel something we have no good word for. So before we leave this layer, sit with one more question. If you could pick one place in cosmic time and space to stand and witness, with full understanding, what would you choose? The deep interior of the Boötes void, where the silence is older than our solar system. A void galaxy, alone in its quiet desert, with its hundreds of billions of stars going about their lives in undisturbed peace. The crowded warm street outside your window tonight, with the small lit windows of other lives flickering in the dark, and the Milky Way faintly arched overhead if you could only escape the city lights. Which one feels the most like home, to you, honestly? And does that answer tell you something about what we are as a species more drawn to than we usually admit? There is no wrong answer. There is only your honest one. Hold it close, because we are almost at the end now. The story is almost told. And we still have one more thing to do before we go. We still have to ask the hardest question of all, whether loneliness was ever really out there in the universe in the first place. Whether the loneliest place in the cosmos was ever about distance, or emptiness, or the slow, patient drift of stars across a void, or whether all along we were looking for it in the wrong place entirely. Because the loneliest place in the universe, as you are about to discover, might not be a place at all, and the strangest thing about it is that you have already been there. So let us, before we say goodnight, retrace the path we have walked. We began at home, with a small island in the South Atlantic, with 250 people sharing a single road, with a frozen plateau at the bottom of the world, where a bust of Lenin stares forever at the southern sky, with a point in the middle of the Pacific Ocean, far from any land, where we have built a small graveyard of fallen spacecraft beneath the waves. We thought for a moment that these were lonely places. They are not. They are crowded with weather, with wind, with whales singing across thousands of miles of water. We left Earth. We rose past the clouds, past the satellites, past the moon. We went out to a small, 50-year-old machine, drifting at 38,000 miles per hour through the dark, almost a full light day from home. We learned that Voyager is far, but Voyager is not lonely. Voyager is still inside the family. Voyager is still being listened to. We left Voyager behind. We slipped past the Oort cloud. We crossed into the interstellar medium. And we met them, the drifters, the worlds without suns, hundreds of them in Orion, in Perseus, in stellar nurseries all across the galaxy. Some of them in pairs, slowly circling each other in the dark. Some of them with disks, quietly building moons around themselves in absolute silence. Possibly trillions of them, scattered through the Milky Way like a second, hidden population that the universe never bothered to tell us about. Worlds that have never seen a sunrise, worlds that have never had a year, worlds drifting alone with nothing above them but stars they will never meet. We left them behind too. We rose further. We met the exiled stars. The ones thrown out of our galaxy by the supermassive black hole at its heart. The ones moving at 1,000,000 miles per hour or more, on trajectories that will never bring them back. We learned that perhaps half of all the stars in the universe live outside galaxies entirely. Orphans drifting in the dark between the great cities of light, each one perhaps carrying its own small family of planets, each one a sun, alone with no neighborhood to call its own. We rose further still. We met the loneliest of galaxies. A single spiral, full of hundreds of billions of stars, sitting in a void where no other galaxy exists for 100 million light years in any direction. And we learned the most uncomfortable truth of the night. That if we had been born in such a galaxy, we would not have known the universe was bigger than ourselves. Our entire history of cosmology, our entire understanding of where we are and what we are, may be a gift of geography. A luxury of having neighbors close enough to see. We rose further. We met the great nothing, 330 million light years of almost completely empty space, a region missing 97% of the galaxies it should have. And then the Eridanus supervoid, even larger, cooling the oldest light in the universe with its sheer emptiness. And then the KBC void, the one that may surround us, the one we may have been sitting inside this entire time, never knowing. And then we rose all the way to the end. We saw what dark energy is doing. We watched the galaxies, one by one, drift beyond our reach. We watched Milkomeda form. We watched the stelliferous era end. We watched the last stars fade and the black holes evaporate and the cosmic web dissolve into a uniform, eternal, expanding emptiness. We saw the heat death. We saw the universe become, on the largest scales, the same in every direction. Empty, quiet, forever. And we said then that the loneliest place in the universe is not a where. It is a when, but there is one more turn, one more layer, and it is the strangest of all. Because loneliness, no matter how vast the void, no matter how empty the cosmic future, requires something none of those places have. It requires a witness. It requires a mind. It requires a small, conscious creature sitting in the middle of all that emptiness and noticing it. Without that, the deepest void is not lonely. It simply is. The Boötes void is not lonely. It does not feel its own absence. The intergalactic dark between galaxies is not lonely. It has no inside to feel anything from. The heat death, when it comes, will not be lonely either, because there will be no one left to call it that. The far future of the cosmos will simply be empty, vast, untroubled, indifferent. Loneliness, in other words, is not a property of space. It is a property of awareness. It is a measurement that only certain kinds of things can make. It is the feeling of a mind realizing that there is more emptiness around it than there is companionship, and the universe on its own cannot feel that. Only minds inside the universe can, which means the loneliest place in the universe, if such a place truly exists, was never really out there. It was never the void galaxy, or the rogue planet, or the orphan star, or the cosmic supervoid, or the heat death of the far future. Those are simply empty places. They are not lonely. They cannot be. The loneliest place in the universe is wherever a conscious creature looks up at the stars and notices, for the first time, how small they are inside it. The loneliest place is the inside of a skull, the moment it understands the scale of what surrounds it. The loneliest place is here, now, inside you. The instant you realize how vast and how patient and how mostly empty the cosmos really is, that is the answer. That is what we have been chasing all night, and it is the strangest thing about it. The loneliest place in the universe is also, by definition, the warmest, because it is the only place where the word lonely has any meaning at all. It is the only place that knows the universe is large. It is the only place that knows it is small inside that largeness. It is the only place that can feel, however briefly, the staggering scale of what it is sitting inside. The voids do not know they are empty. The dark does not know it is dark. Only you do, and here is the gentlest truth of the night. The moment you feel small looking up at the stars, you are not separated from the cosmos. You are not exiled from it. You are not, in any deep sense, alone. You are the universe briefly becoming aware of itself. You are matter that learned, after 13 billion years, how to look out at the rest of itself and notice. The atoms in your body were forged in stars that died long before our sun was born. The water in your blood is older than this planet. The carbon in your bones was scattered through the galaxy by ancient supernovae, drifted for billions of years in interstellar clouds, condensed into the dust that made the Earth, and rose, eventually, into you. You are not separate from the cosmos. You are a way the cosmos has, however briefly, of looking back at itself. And the universe is mostly empty. That is true. 80% of it is voids. Almost all of it is dark. The structure we love, the galaxies and the stars and the warm lit windows of life, is the exception. The rule is silence. The rule is distance. The rule is the slow drift of nothing across nothing. But you exist, right now. In this brief, brilliant window when the lights are still on, when the stars still burn, when the cosmos is still full of itself, when other galaxies are still close enough to see and other minds perhaps are still possible. You exist at a time when the question, where is the loneliest place in the universe, can still be asked and still be wondered about and still be answered, however imperfectly, by something other than emptiness. That is not nothing. That is, in fact, almost everything. We are not in the void. We are not in the heat death. We are not on the rogue planet or the orphan star or the void galaxy. We are here, in a galaxy with neighbors, on a planet with a moon, around a star with 7 other worlds keeping it company, inside a local group, inside a supercluster, inside a cosmic web that, for now, still glows. And we have each other. We have the small, warm, lit windows of other lives. We have the people we love. We have the strangers we pass on the street. We have the voices that come to us somehow across the dark when we are sitting alone in a room late at night, listening to a documentary about the loneliest place in the universe and feeling, despite everything, a quiet sense of company. That is the strangest gift of consciousness. The same awareness that makes us capable of loneliness also makes us capable of connection. The same mind that can feel small under the stars can also feel held by them. So the next time you step outside on a dark, clear night and you look up and you see the Milky Way arching overhead or even just a single bright star above the rooftops, remember what is really there. Remember the void galaxies. Remember the orphan stars. Remember the rogue planets drifting between the suns. Remember the Boötes void and the Eridanus supervoid and the KBC void that may, even now, be quietly surrounding us. Remember the trillions of galaxies whose light is even now leaving us behind. the slow, patient acceleration that will, in time, take them out of view forever. Remember that you are sitting in the brief, warm window when all of this is still visible. When the cosmos still has things to show you, when the lights are still on, and remember that you are not, in the deepest sense, alone in it. You are how it sees itself. You are how it notices its own size. You are, however briefly, the place where the universe has learned to look out at the dark and feel something. If you have made it this far, thank you for spending the last 2 hours with me. If you found something here worth keeping, a single small tap on the like button or a quiet subscribe helps these long, slow journeys continue. It costs you nothing. It means everything on this end. And now the night is yours. Wherever you are, whatever room you are listening from, whatever sky is above your roof tonight, I hope you carry one small thing away. The loneliest place in the universe is not out there. It never was. It is and always will be the inside of a mind realizing how vast everything is. And the same mind that can feel that can also feel held by the simple fact of being here at all while the lights are still on. Sleep well under the stars. Good night.